rather than using the randomization technique to conduct inference about two population proportions from independent samples, we can instead use a sampling distribution of the difference of two proportions and then therefore the normal model. Okay, so here's how this is going to work. Suppose a simple random sample of size N1 is taken from a population where X1 of the individuals have a specified characteristic, and a simple random sample of size N2 is independently taken from a different population where X2 of the individuals have a specified characteristic. The sampling distribution of P hat 1 minus P hat 2, where P hat 1 is X1 over N1, P hat 2 is X2 over N2, is going to be approximately normal, where the mean is P1 minus P2, and the standard deviation is this mess right here. Provided N times P hat 1, 1 minus P hat 1 is at least 10, N2 P hat 2, 1 minus P hat 2 is at least 10, and the sample size is no more than 5% of the population size for each of the two samples. And so this is close to what we did when we did a sampling distribution for a single proportion. Okay, I'll elaborate more on what's in that gray box in a sec because I know that looks a little bit overwhelming. Here's the bottom line and how we're going to go about doing this hypothesis test. First and foremost, you have to have model conditions satisfied. There are three model conditions. Condition number 1, the samples are obtained independently using simple random sampling. Or you can obtain the data through a completely randomized experiment where you have two levels of treatment. In either case, the response variable, the variable of interest, has to be qualitative with two possible outcomes. Either you have some characteristic or you don't. For each of those two samples, N times P hat times 1 minus P hat must be at least 10. That's the typical or usual normality condition. And then we have our independence condition, namely the sample size can be no more than 5% of the population size. So once those three factors or requirements are satisfied, these are the steps that we can follow to conduct a hypothesis test using the normal model. Step 1, determine the null and alternative hypothesis. This is your typical left-tailed, right-tailed, two-tailed structure. Step 2 is the textbook step. Decide on a level of significance alpha. Step 3, for our class, we are not going to be using this classical approach. We are going to exclusively be using the p-value approach, and we will rely on StatCrunch to get us the value or get us the p-value. Step 4, if the p is low, the null must go. And then step 5, state your conclusion. All right, so let's do the same belief in ghost problem that we just looked at when we did randomization. In a recent Harris interactive survey, individuals were asked, do you believe in ghosts? Among 510 teens, 224 said, yes, I believe in ghosts. Among 2463 adults, 1,010 said, yes, I believe in ghosts. Is there a difference in the belief of ghosts between the two groups? So first, we want to make sure that our model requirements are satisfied. We have independent sampling here, where we're comparing two groups, teens to adults. The response variable is qualitative with two outcomes. Either you have the characteristic that you believe in ghosts or you don't. Step 2 is we want to verify our normality conditions. Let's compute p hat for each of our two groups. P hat for the teens is going to be 224 out of 510. 224 have the characteristic I believe in ghosts out of the 510 surveyed. That gives me a sample proportion of 0.439. P hat for the adults. I had 1,010 adults that said, yes, I believe in ghosts out of the 2463 that are in my study. That gives me a p hat of 0.410. Now what I want to do to get my normality condition is compute n times p hat for teens, 1 minus p hat for teens. That would be 510 times 0.439, 1 minus 0.439. I'm getting 125.6, which is certainly at least 10. And then I would do the same thing for my adults. My adults, the sample size is massive at 2463, so I'm pretty confident that that's going to be at least 10 as well. You agree to be at least 10?
Yeah.
Yeah.
And then the next is my sample size no more than 5% of the population size. How many teens are there age 13 to 17 out there? I have no idea, but I'm sure it's in excess of 5 million, right? So 5% of 5 million is certainly more than the 510 we surveyed. How many adults are there 18 years or older? It's well in excess of 100 million. So my 2463 is certainly less than 5% of my population size there as well. And so I feel good about that. So now I can go through my 5 steps. The statement of no change, no effect, no difference is the proportion of teens who believe in ghosts is no different or the same as the proportion of adults. We're asking, is there a difference? And so is the proportion of teens different from the proportion of adults who believe in ghosts? We're going to be using a 0.05 level of significance. And now we go ahead and use StatCrunch to get our p-value. To use StatCrunch, you're going to go stat, proportion stats, to sample, and you either choose with data or with summary. Here we have summarized results, so we're going to pick with summary. I'm going to leave that up because that's our ghost one. So we go stat, proportion stats, to sample with summary. Sample 1 is our teens. Our teens. We had 224 out of 510 say, yes, I believe in ghosts. 224 out of 510. Sample 2, my adults. We had 1,010 out of 2463. 1,010 out of 2463 said, yes, I believe in ghosts. We're going to be performing a hypothesis test for the difference of 2 proportions. If you look back here, my null is that the proportion of teens equals the proportion of adults. That's equivalent to saying the proportion of teens minus the proportion of adults equals 0. And so in StatCrunch, that's what we're entering right here is P1 minus P2 equals 0 is equivalent to saying P1 equals P2. Click compute, and bada bang, we get our p-value of 0.224. See it right there? So there's my p-value of 0.224. Here's how we would interpret that. If there is no difference in the proportion of teens and adults who believe in ghosts, in other words, if the statement in the null hypothesis is true, we would expect a difference in sample proportions as extreme or more extreme than that observed. Our difference in sample proportions is right here, by the way, at 0.029. That's the sample proportion of teens minus the sample proportion of adults who believe in ghosts. So that's what, when I say as extreme or more extreme, it's because this is a two-tailed test. So it could be 0.029 or higher, or negative 0.029 or less. As extreme or more extreme than that observed in about 22 of every 100 repetitions of this study. In other words, we did not observe anything that's unusual if under the assumption the proportion of teens is the same as the proportion of adults who believe in ghosts. And so now I can do my step 5, which is to state the conclusion: there is not sufficient evidence to conclude there is a difference in the proportion of teens versus proportion of adults who believe in ghosts. There's just not enough evidence to say there's a difference between the two.